Okay, good. So welcome back. So today we're going to start, you know, a new chapter, and we will be looking at how to control the program flow. All right. So we will be talking about the controlling the program flow. Now, in the previous classes, right, we had discussed about looping, right? We had talked about looping. So in today's class, we are going to learn statements, right? That is going to help you in conditional branching. Okay. Now, what we are going to learn is if you have actually, gone through my first few class lectures or videos, then you must have noticed that I had drawn some kind of a rough figure where I had told you that programming is all about looping. It's all about writing straight sentences or statements. And the third one was where we do branching, right? So this is what we are going to start today. So we are going to start looking at this part. We have already seen how we can write statements, how we can write operators, how we can actually perform calculations using operators. We have also seen how we can do the looping in a programming, in a program. But today we're going to look at how we can do this conditional branching. Okay, so conditional branching, or we also call it as jumping. Okay, now we will be learning, certain statements in order to do this conditional branching. And the statements that we are actually going to do are the following. So the first one that we're going to do is the if statement. Then the second one is going to be the else statement. Then we will be doing the switch. I remember in the program, in the lab, you have been doing switch cases also, right? So there's no problem if you know or if you are doing it, but we will cover the switch cases. Then there are two keywords, right? There is a keyword called as break and the another keyword which is called as continue. So these are the two keywords that we are going to cover. So mainly these three are going to help you in doing your conditional branching. Okay, so let's continue and see what exactly conditional branching is all about. Okay, now if life would be a straight line, it would be really boring, isn't it? If everything is a straight line, it's kind of boring, right? The same thing is also true for programming. So it will be too dull if the statements in your program could only be executed in the order in which they appear. That means one below the other. So if the statements would appear one, they normally we write one below the other, and if they would execute in the same order, then things will not be interesting, right? Now the fact, in fact, the most one of the most important tasks of a program is to instruct the computer to branch. Branch meaning jump to different portions of the code. Now, where are we jumping? We are jumping to different parts of the code and work on different jobs wherever the specified conditions are met, or whenever the specified conditions are met, jump to different parts of the code. And that makes our programming more flexible. It makes us our programming more interesting, right? Now, in most of the cases, you don't know in advance what will come next. For example, when you are going somewhere, you don't know what can come, right? Because you cannot plan for the future. You cannot predict anything in the future as such, but you kind of have your options that, I'm going to the market. I don't know whether it's going to rain or not, right? But in case it rains, what should I do? So probably you keep that in your mind. You cannot be very sure, or you cannot be absolutely sure that yes, today it's going to rain, so when I go to the market it is going to rain, right? But there are some options, there are some conditions, and those conditions you can visualize from before, like, okay, fine, there are these 4 or 3 different conditions which can come up. I'm going to the market, there could be, it may rain. So if it rains, what should I do? If it doesn't rain, what should I do? Right? Today there's going to be a cricket match, right? So I went to the stadium to watch the match. So there could be 2 scenarios. Like suppose it's a 50 overs match. So you have planned to go and watch cricket, but the forecast is not quite good. That means there could be a scenario that it would rain, or if you look, so in case it rains, what are you going to do, right? That's the second point. So you will have to, kind of make certain, you need to give yourself options. Okay, you need to give yourself options. Options means if it doesn't rain, I'm going to do this, but if it rains, I'm going to do that. Okay, so in most cases you don't know in advance what will come next. What you do know is that something is bound to happen if certain conditions are met. Like for example, if it rains, then we know that we will go for a movie. If it doesn't rain, we will go and play, we'll go and watch a cricket match. Therefore you can just write down the tasks and the conditions in the program. The decisions of when to perform the tasks are made by the conditional branching statements. That's where conditional branching becomes important. Okay, so in C, in C programming, if statement is the most popular and the most common way of doing branching. Okay, if statement. So we will start with the if statement. This is the most common way of doing your branching. Okay, now it can be used to evaluate the conditions as well as to make decisions whether the block of code controlled by the statement is going to be executed or not. So if consists of two things. One is which conditions are defined. So you can define the conditions using this, and also what to execute. For example, this is basically, suppose here is a condition. So at this point of time, here, this is my condition, right? This is my condition in branching. And second thing is these are two different blocks of code, right? So if this condition satisfies or it doesn't satisfy, if it satisfies, then we need to execute this part of the code. If it doesn't satisfy, then we need to execute this part of the code. So using your if statements, you can control this entire thing here. Okay, so rather than discussing the theory, right, I can actually show you a small program, and then we can discuss how exactly this if statement works. So let's see if I can write a small program to show you how this entire if statement works. Okay, so I'm writing a small C++ programming. So just try and follow what I'm writing. So the first thing everybody is absolutely clear is your hash include, right? So everybody is clear about hash include. So I need to write this header file because since I'm going to use a printf function, right? The printf function is included in the stdio.h. So I start with the main method, right? So let me write that it returns an integer. Now I can declare, let me declare an integer variable, right? Which is I. Now what I do is, let's write a program. Okay, so I'm going to just write a statement. So let's say integers that can be divided by both, say, 2 and 3. So we will generate some numbers which can be divided by both 2 and 3. Okay, so let's see how many people have joined the class. Okay, more than 50, so that's good. All right, so this is basically my program is going to be. So let's and let's also put in a range. Okay, so we will try to generate. We'll try to generate like all those numbers which are divisible by both 2 and 3, and we will only look at numbers till 100. So we will not go beyond that. Okay, so let's look at this. So first thing, let me write a for statement, because let me generate a loop. So I'm going to write a for statement. For I is equal to all of you are able to follow this, right? I is less than equal to 100, and then we can have I plus plus. Now all of you are familiar with what I'm doing here because we've done this in the previous classes, and here I'm opening a bracket because all the statements which I want to be inside this for loop, I'm going to write here. So inside the, now what I've done is I have written a for loop to run this loop 100 times because I am looking at generating numbers, generating those numbers which are divisible by both 2 and 3, right? And I want to give a range till 100. So I need my loop to execute or run 100 times. And every time I'll be checking whether a particular number is divisible by 2 or not. Okay, so now I write my if statement. Now this is where I'm doing the conditional branching. Now what I'm saying here is if I is divisible by 2. Now this operator, if a remainder returns, then this becomes false. Okay, so this will only, you know, this, suppose you have 4 and 2, if the this will return the remainder. So in this case the remainder is 0, so it will return 0. If there is a remainder, then suppose if it were doing 5 and this percentage 2, then it will return the value 1. That means it will return the remainder. So with this we can easily write a program to check whether a number is divisible by 2 or 3 or any other number or not. So in this case we are checking for a condition I value, whatever the I value will be generated, we will check if divisible by 2 will give a remainder or not. Okay, so if it doesn't give a remainder, so if this statement means that it is divisible by 2, and also I'm going to check for another statement which is divisible by 3, right? Because I have mentioned in my program that I'm going to check for two conditions. One is divisible by 2 and the other one is divisible by 3. So this is the way the syntax for if is written, if this is the condition, right? But in my program, I have written a little complex condition. Okay, so I have written a complex condition. Why it is complex condition? Because I'm checking for two conditions. So you know that we have used these operators, right? And or. So here this is an and operator, conditional operator. So here I'm checking for whether I is divisible by 2 and I is divisible by 3 or not. Okay, this returns the remainder. This returns the remainder. So if I have like 2 divided by 2, this will return the quotient. Okay, this will return the quotient. So if you do 2 percentage 2, this will return the remainder. So just remember that. Okay, now in case both the conditions are satisfied, that means if a number I is divisible by 2, yes, it will return 0, or I is divisible by 3. Then what I'm going to do, I'm going to print. I'm going to print, say, I will give some gap and percentage D, and let me write this comma I. So I'm going to print the value of I, and then I, the bracket which I've opened here, I need to close it. So here is my bracket which is closed. Now I'm going to do return 0 because this integer I need to return something, right? And then for this bracket I need to close it. So here is my program. Okay, so this is a complete program now, and what this program is going to do is it is going to, let's do a dry run and see what exactly is going to happen. So you can try this in the lab. So first the value of I is going to start with 0. So it comes to this, so I is equal to 0. So it's going to check for this condition. Is I less than or equal to 100? Yes, it is. So then it will enter the for loop. So when it enters the for loop, this is the first statement that it reaches. Now here it is going to check that is this condition met. So I, which is 0, percentage 2 will give you 0, right? So if you are dividing 0 with anything, what is the value that you get? 0 divided by anything is 0, right? So this is fine. This is true. And then it is going to check for the second condition. So in this case also, I percentage 3. That means in this case, what's happening? 0 is being divided by 3, and this is also 0. So both are 0. So when both are 0, this entire statement becomes true, right? That means this condition is satisfied. That means this is 0 and this is 0. So this whole thing, because this is AND, so this is true, this is true. So true and true, that means 1 and 1 is equal to 1. So this entire statement becomes true. So if it is true, then it goes here and prints. So what is going to print here? It is going to print. So I'm doing percentage %t, that means I'm going to print an integer. And what is the value of I here? I value is 0. So what gets printed? It gets printed 0. So the first number which will get printed is 0. Now what happens is this I++ is executed. So I++, what it does is it changes the value of I to 1. Now it checks, is 1 less than equal to 100? Yes, the condition is satisfied. It comes back once again to this statement. Now the value of I is 1. So 1 percentage 2, what is the answer? It's like 1 divided by 2. What will be the remainder? Remainder is 1. So if the remainder is 1 here, this becomes false. This condition is not met. Similarly, this will also be false. So if it is false, it will not go and print that number. It will not go to this line. What will happen? It will go here and the I value will get incremented to 3. So what happens when, it will get incremented to 2 because the last I value was 1. So when it goes here, the value of I becomes 2 now. So the condition is checked. Is 2 less than equal to 100? Yes, it is. So it will come back to the statement and it will check this. Now 2 percentage 2, right? This is called as mod operator. Okay, this is called as mod operator. So 2, so I'm writing because there's a symbol as percentage, then I'm just saying percentage, but this operator is called as modulus operator. So 2 percentage 2 is what? The remainder is 0. So this becomes true, but 2 percentage 3 is not 0. That means this is false. So true and false, overall this entire statement, this statement becomes false. That means it will not get into the loop. So 2 will not get printed, neither. So still we have 0 which is printed. So which is the number which is actually divisible by both 2 and 3? So 2 is not, 3 is not, 4 is not, 5 is not, 6. So similarly, when the value of I reaches 6, you will have 6 percentage 2 0, yes. 6 percentage 3 0, yes. So all this entire statement becomes true. So value 6 is going to get printed. So if you run this program, you will have values like 0, 6, 12, okay, and 18. So these are all the numbers which are divisible by 8 and 2 and 3 are going to get printed. Now we are going to check this condition till 100. So till the value of I reaches 100, this entire numbers will keep getting printed. As soon as it reaches 100, 101, so I value once it becomes 101, is 101 less than equal to 100? No. So this loop will terminate. It will come to this particular place and the program will exit here. Okay, so just make a note of how this if condition works. Did you all understand this?
Yes, sir.
Yeah. Okay.
Yes, sir.
So this is how the if condition works, right? So it's very simple to understand. Okay, and then you have another statement which is if else. Okay, if else statement is also a very simple usage. So I will show you exactly how that if else works. So you have written the program for switch case, right? Have you done programs using if
Yes,
else
sir.
also?
Yes, sir.
Okay, so
Yes, sir.
anybody has got a doubt with how you use if else, and do you have any problems with that?
No,
Okay,
sir.
No, sir.
let me just write a small program for those people who are new to programming and who are doing it for the first time, right? So that it's clear for them also. So I'm writing for if else. So let me write a small program to demonstrate how we can use if else. So I'm writing this program and you have to tell me what this program is going to do. Okay, just follow this. So just,
So the output, we have to see the output.
sorry.
We have to see the output, what's
Yeah,
coming.
yeah, you have to tell me what is the output. Okay. So I'm just writing a simple program and you have to tell me what is going to be the output here. Let's see. This will just also be a small revision for you because some of the things that I'm going to write in this program is from the previous chapter. So let's see how much you remember. Now watch carefully what I'm doing, okay? It's a very simple program. So here is my loop. Okay, the next line you need to be here. I'm using else. So in this case, if this condition is satisfied, it will go and print this. Else, that means here we are talking about this. Okay. So in the previous example, when you use if, it's like you go here. If the condition is satisfied, go and do this. Otherwise, don't do anything. But in this program, I've written, this is the condition. If the condition is satisfied, do this, else do this. So this is the true branching that we are doing here. Here, actually in the previous example, we were just looking at a condition and then we were checking whether we should go ahead or not. So if that condition is satisfied, we go ahead. If this condition is not satisfied, we don't go ahead. But in this if else, we check alternative paths to go. So if the condition is satisfied, then we need to go and execute this. Otherwise, we go and execute this. So execute 1 or execute 2. So 1 is this. So if the condition is satisfied, go and execute this. Otherwise, execute the second line which I'm writing. Okay, so look at this line very carefully and I hope you figure out what I am going to do here. So who remembers what I did here? Can anyone tell me what I've done?
So the first zero will be checked that it's even or odd.
Okay. So can you tell me what is going to get printed here? Who is going to tell me? What is going to get printed? What will be the output of this program?
So in if condition, if the number is even, then it's going to be print, and if in else condition, it's going to print odd number, but in vertically, so down by down.
Vertically? Okay, so one thing is for sure that here, this is how
Even
this
number is going to print in a line,
yes.
but odd number going to be print in one by one downward, sir.
Okay. So if you look at this program, it's very obvious that we start with 0, right? We start with 0, so the I value becomes 0. So first thing is this line is going to print something on the screen like this. So it is going to print even number, right? I'm writing in short, and then with a space, it is going to print odd number here, right? This is how the first line will be getting printed. Okay, now that's it. And then let me just add a /n here. So what happens is, then if we don't confuse it, so once we add /n here, then the next printing will start here. Now what we're doing is we're checking for the value of 0. So first I value is 0, so it is going to come to this 0%2 is 0. So this is satisfied. That means 0 divided by 2 is 0, right? So this is true. So if it is true, it is going to print this. So it is going to come to this statement. And what is going to get printed? The value of I. So what is the value of I? The value of I is 0. So what's going to happen? We are going to get 0 printed here. All right. Now it will not go and execute this statement itself because we have already satisfied this. But since we are running a for loop, it will go and increment the value of I and run the second loop. So if the value of I is now, what is the value of I? The value of I changes from 0 to 1. Is this condition satisfied? Yes. So 1 is less than 10. So now it will come again here. Now in this case, what's going to happen is 1 divided by 0 is not equal to 0. 1 not divided, sorry, 1 modulo 2 is not equal to 0. That means the remainder is 1. So this condition is not satisfied. So if this is not valid, then do the else part. So if this is not true, then else. Else means I'm going to print. Now what I'm doing is when I'm printing, now look at this, when I'm printing here, right, I am printing with some format. I have given a space of 14 characters and then I'm going to print. So what's going to happen is if I don't write 14 here, the next value 1 is going to get printed here. Okay, 1 is going to get printed here. So since I have given 14, that means it is going to leave space of 14 characters. So from here, it will leave 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So after leaving 14 spaces, that means 14D, it is going to print 1. Are you able to understand? Now I have written /n. So when I've written /n, it will go to the next line. So in the next line, the value of I again, because the for loop will execute for the second time, in fact, the third time here, the I value will become 2. So again, it will check this condition is 2 modulo 2. Yes, this satisfied. So what it's going to print? It's going to print 2. That means the value of I. So it's going to print 2 here. Now I have not put a /n. That means the printing will continue in the same line. So now it will go back to this loop again and check for the I value. So I value now is 3. So 3 modulo 2 is not 0. So this is not satisfied. So it will not go and print this. But where it will go, it will execute the else part. So it will come to this particular line. And now it's going to again format it. By leaving 14 spaces, it's going to print the value of 3. So again, we leave the 14 spaces and print the value 3. Okay. Now, again, this will go to the next line because I have /n. So the next printing will happen here. So this will continue and you will get something like, so all the even numbers will get printed here and all the odd numbers will get printed in this manner. So you will have 6, 7, and you'll have 8 and 9. Because once it reaches I plus plus 10, this condition is not satisfied. But if I would have done something like this, if I is less than or equal to 10, that means it would have run for the 10th time. So it will print 10 here, but nothing will get printed here. Okay. But so did you understand this?
Yes, sir.
Yes, sir.
Yeah. Everybody, did you understand what I've done? So in this example, I have used if and I have used else. Okay. So these are the two things that I have used here, if and else. Okay. Now we have, we can also do nesting. What is the meaning of nesting? Like, I think we had done the nesting of loops, right? We had done for loop, and inside a for loop, we had used another for loop. So
Yes.
just like how you can do nesting of for loop, we can also nest your if conditions. Now, nesting of if conditions actually, brings about the complexity in the code. For example, what do I mean by nesting of if conditions? So What it means is like, suppose I have, say, if statement. I can write if statement inside an if statement. Okay, so I can write some, 1 second, sorry. So I can do like if do this, right? If this condition is met, and then again I can write another if, then I can write another if, and then I can execute this if. I can write the statements for this, else do something here. For this I can use else. For this I can use else, right? So if you look at the if block, so if block is something like this, and inside this I can write another if block, and inside this I can write another if block. So what we can do is, this is called as nesting of if. Okay, now nesting brings about a complexity. Why it brings about a complexity? Because yes, to 1 or 2 level it is fine. So for example, if I is greater than 0, then do something, or let me write a program. Then we'll be absolutely clear about what we are trying to do. So I'm just going to write another program. Let's see whether you guys can understand what I'm writing or not. So just look at the program that I'm writing carefully. Okay. All right. So just look at the careful. Just try and follow what I'm writing. Now you have to tell me the output of this, okay? So all of you, please look at this carefully. And you can also make a note so that you can do a dry run and tell me exactly what is going to be the output of this program. I hope all of you are just trying to understand this program. Okay, fine. Now who's going to tell me what is going to be the output here? Okay, what I'm going to do is, all of you please write this program down. Okay, please make a note of this program, and I'm giving this as a homework. You are going to run this program if you have a computer. If not, you're going to do a dry run, and then in the next class you're going to tell me what is going to be the output. Is that clear? Are you
Yes,
able to
sir.
hear me? Okay, fine. Okay, so once we do this nesting of loop, once we are clear about what exactly is nesting of loop, then we will look at switch case. Now, switch case is basically a way by which your nesting of loops can be avoided. All right. So nesting of loops. Now, in this case, see, we have only two loop if left. So we have used one if under the another if. That means we are doing only one level of nesting. But you can do multiple level of nesting also. You can do 3 or 4. But when you do 3 or 4 levels, or if you go more than 2 levels, then what happens is that things will become really complex. Your program will become very complex. It will be difficult for you to comprehend your own program. Okay, nested if statements are used when there are successive related decisions to be made. That means one after the other if the decisions are all relative. Okay, so it's scenario something like this. You go here and there's an if condition, and you go inside this, there's another if, you go inside this, there's another condition. So this is how this branching becomes more and more complex, and then you have another branching here. So this is complexity. Okay, if this is complexity, so you can have multiple levels of nesting of if statements, but it becomes complex. So you know what we do is a programmer will sometimes have a problem in just keeping track of the series of complex nested if statements. So if you go and look at a code, and if it has like too many nested if, you will not be able to even figure out like what's happening, because our mind is only capable of kind of relating, understanding 2 or 3 levels. Once it goes beyond it, then it forgets the previous ones. So in order to make our programming simple, right, we have, fortunately, there is another statement in C, which is called a switch statement. Switch statement can be used to make unlimited decisions or choices based on a value of a conditional expression. And most of the time, the nesting or what you call the nesting of if conditions can be avoided, and in place of that, we use the switch conditions. Okay, so tomorrow I will actually cover up the switch conditions. So today's class we will only cover till here, and please write this program which I have written down and try to understand this. Okay, so the most important thing is not about running and getting the output, but trying to understand what is happening, and if you can figure out the output yourself, that is great. So without running this program, without typing and executing this program, try to understand and try and see what is the output of this program going to be. And then you type this program into your computer and then see whether the output that you had thought of matches with the output that is coming on the computer. If it matches, you have understood the concept of nesting of if perfectly. If it doesn't match, try to look at the program and see where you made a mistake, where you could not figure out. And still, if you have a problem, then you let me know. I will explain exactly what is happening in the code. Okay, so now you guys
Sir,
can, yes.
sir, maybe I'm wrong, but I think that sir is going to print sir negative number and odd and even also. Like
Yeah,
in negative.
you try it. You have time. You take your time and look at it. Okay. I know the answer. I know the answer. So you try and figure out what's happening. You write down what is going to be the output, and then you run this program and see whether you get the same output or not. If it matches, you're bang on. You have understood. If it doesn't match, see where you went wrong and try to figure out. And if you're still not able to figure out, then you ask me. So I don't know where I'm making a mistake, or why my answer is not matching. This is what I have got, but this is what I'm getting. So why my answer is not matching? So you show me output, I will tell you exactly where is the mistake or where you are thinking wrong. Is it clear? So all of you, please write down your roll number in the chat box so that I can take your attendance. In tomorrow's class, I will be covering the switch statement, right? And I will also cover the break statement and the continue statement. Okay, so I will also show you a technique of how you can use an infinite loop in your program, and also how I can end the infinite loop using a break statement. So infinite loops are sometimes very important also. We talk about, infinite loop is not good because it makes your program, run infinitely. But sometimes we use infinite loops, you know, in order to take input from the user. So the user can keep, entering values from the keyboard until he wants to break it. So once he enters a value which I have defined as a break for the infinite loop, then the program will stop accepting the values from the keyboard. So infinite loops are also helpful in taking values from the users continuously. So I will show you exactly what is the use of an infinite loop tomorrow. So in tomorrow's class, we will cover the switch case, the break, continue, and how we can work with the infinite loop. All right. So please do this, and hopefully you will understand. Otherwise, you can ask me. So all of you, please give your attendance. Just write your roll number in full in the chat box. And if you have done that, then you can exit the meeting.
Thank you, sir.